today it's gonna be another version of my pro crypto style of talks, which is we speed run absolutely about a lot of concepts. Try to get as much as possible, hold your seat and put your belt on, and let's go together. So the motivation and goals for this talk are mainly see which are the basic common questions that we have about FHE, what is even FHE, which I will get shortly into now, see where we can apply it, where we have been able to apply it, and see what limitations and alternatives and conclusions about those we have so far found. So FHE, why, how, and what? Basically, the easiest way to map that in your brain is we are able to compute among other people's private data. And so the results are always encrypted, meaning whatever we get out of the computational result, only us can know the answer to. The why this is useful, I mean, you can sort of see this as like an untrusted TEE somehow. So imagine if instead of TEs being in hardware, they were just an encrypted thing that we all work and run on the top of math. There's like a lot less security assumptions that then we need to have. And how we do that? Well, we are based on lots of different primitives, but I would say the most important one is lattices, for example. But this is likely for other more advanced or mathematical talks. So I've tried to abstract basically everything that is related to this core math. What can we build? So one of the first really small explorations that we did was, can we actually make Photoshop, which can be a software as a service, but run on an FHE server? So basically, my picture is private, and the server doesn't know anything about my picture, and I will tell the server I want to do these edits. The server will perform those without knowing anything about the image, and will return me the image encrypted later. So only I can decrypt it. So far, server doesn't learn anything, doesn't know anything at all, but I got my picture edited. And this is basically what we did with Mario here. We can go further. So we created some kind of frog crypto shitty game, I would say. We thought, what if we could do more with our frogs? And so one of the things that we decided is, well, let's make them fight. So now you have an arena which runs on a server that is basically performing all of the FHE stuff. And so you can put your frogs there, they fight, and you just know what was the outcome of the fight. But you don't learn the strategy of the rivals, you don't learn absolutely anything at all, which can be fun, can be useless. I'm not really sure, but up for you to judge. The two most important reasons we learn is that it's a big pain to write these things. Like the Photoshop was okay because it was a negative of an image. Then we got into the Pokemon kind of thing, and it started to be like, it's taking me time to write this. And the more you want to do, the much harder it becomes. So writing Boolean circuits by hand was not going to work. The second thing was we found a way to actually crack this thing up, which I will go through in a minute. So in terms of speed and it being terribly slow when you want to start doing more elaborated things, there's a really nice talk by Neil Imert, which you can fetch on YouTube in the Ingonyama channel. He basically cracked a way to do really fast entities. And summarizing it a lot, entity is the core operation of FHE, which is embedded into bootstrapping. So the general idea that I want you to get from there is we can perform 65,001,024 entity point entities in 1 second. So if we can adapt our problems to look on this way, well, it looks promising that we will get some significant performance in order to do more things. The second thing is, what do we want to build now? And so forwarding that, there's some ideas that we have discussed. Of course, this is not like we are committing to do that, but these are just ideas that have flourished from this exploration. We can do private social trust graphs, meaning I can basically say how much do I trust people in a completely private graph that no one can see. And we can make queries to this graph about any other person, and we will know how much we can trust them based on how much we trust our peers. No one learns absolutely anything about our relations, but we get useful information out of it. The second one could be we do private web search at civilization scale. So imagine we can do these private information retrieval protocols, and we get Google's index database, we perform an encrypted search, and we get encrypted results out of it. So we are just bringing completely private, no incognito mode stuff, web searching for anyone to be used. Questions and conclusions. It was really cool. FHE is slow, and it will be like that maybe for some time, but it's really powerful. One of the things we worry is, well, there's maybe like primitives that are more powerful than that. And if we know those exist, should we focus on FHE? Because maybe we can just focus on the next thing and like get even more benefits and more powerful primitives. Is MPC enough? Like, are we overkilling with the problems and the solutions that we over-engineered here? And how much can we optimize this? How can we move forward? Like, I would say this is like the classical type of stuff that I think we got some insights and that we have further questions on. So